Okay, so if you are trying to figure out how to graph this function, well, first of all, we got to write the equation, then we can actually work on the graph. So the equation is a radical with a vertical stretch of -1. So a vertical stretch of -1, if we think about just the parent graph, or sorry, the parent function, it looks like this. Now you can use H or C, and you could use K or D. I don't care. I'll kind of use both as we go through the year. But the vertical stretch is your A value. So this should be -1. So if I look through all of my choices have that as -1. So I can't eliminate anything from that. Some of the other things that are easy to figure out is a shift up of 3. So this is going to be 3. Okay, so right away then I can eliminate this choice here because that has a -3. And then I have a shift right of 2. So that means what we'll see here is going to be x minus 2. Okay, so that means I can eliminate this, and that only leaves me with 2 options. So the last option, it has a horizontal stretch of 1/3. So guys, what that means is that the actual stretch is 1/3. So what we're seeing in the equation, it will be the reciprocal of that. So this is actually going to be 3. So then we can eliminate this choice, which only leaves us with the one left. Now to actually graph this. So I'm going to put the parent graph in here. So I wanted to just focus in on one section of the graph here, all right? So I know that the parent graph, and I'll just use some gray for this. My parent graph has its vertex at 0, 0. And then I know based on the pattern of points, we're going to go to the point 1, 1. And then we'll be at the point 4, 2. And then we'll be at the point 9, 3. So this would be my parent graph, okay? Now, that's helpful because it can help me start to see some important relationships here. The first thing I do is I need to figure out where my vertex is going to be. So my vertex is what the movement left, right, up, and down does to my graph. So if I know that I'm going to move everything right 2 and up 3, then I know that my vertex right here will also be shifted right 2 up 3. So we're going to have the vertex will end up being right here. Now the rest of this is going to come from our vertical stretch and our horizontal stretch. So what I do is I look at the fact that from the vertex to get to my first point, I'm going to go right 1 and up 1. Okay? So whatever my vertical stretch is, I'm going to multiply it times the amount I went up. Whatever my horizontal stretch is, I'm going to multiply it by how much I went left or right. So since my horizontal stretch is 1/3, that means that I'm actually only going to move right 1/3. Now that's not very much, right? And we're talking about just a little bit of a movement there since we're counting by halves here. And then my vertical stretch is 1 or -1. So instead of going up 1 like I would normally do, I'm going to multiply 1 times -1. Well, that means I'm going to actually move down 1. So that's going to put me right here. So the next point on my graph is right there. And that corresponds to this point right here. Let me get my little pointer. Okay, so these points correspond to each other. All right, let's talk about the next set of movements. So let me get rid of this so we have some space to work. All right, so next up, our normal movement to get to the next point is to go right 4 and up 2. Okay, right 4 and up 2. But remember, we're going to multiply our right-left movement by our horizontal stretch and our up-down movement by our vertical stretch. So that means what we're really doing is 4 times 1/3, which is like 4/3, sorry. So it's really like 1.3, repeating. And then we're going to do 2 times -1, which ends up being -2. So what I'm actually going to do is I'm going to go right 1 1/3 from the vertex. That's the key. So let me get rid of these lines here so that I can put my new ones in. Okay, so I'm going to go right 1 1/3. So here's 1 1/3. And then I'm going to go down 2. So down 1, 2. That means my next point is going to be right there. All right, I'm going to do one more. So let me get rid of my sketches here. So we have some room to work. Next up, I'm going to go right 9, up 3. And then I'm going to multiply that by my horizontal stretch and by my vertical stretch. So my vertical stretch is 3 times -1, which means I'm going to go down 3. I'm going to multiply my horizontal, or by my horizontal stretch of 1/3, which means I'm actually going to go right 3. So let's do this. Let me erase again this stuff so we have some room to work. Okay, oops, I don't want to erase that point. Put that back on there. We were like right about there. Okay, so now we're going to go from the vertex. We're going to go right 3. So there's 2, 3. And then we're going to go down 3. So there's 1, 2, 3. So we end up right here. That's my final point. So now I've got 3 points, actually 4 points plus the vertex. Let me get rid of my parent graph here just so I can clean it up a little bit. And you don't have to necessarily get rid of it if you want to keep it. If you want to do all of those calculations on another piece of paper and just use your results to help you graph, that's fine. I'm also going to erase these guidelines. And then I'm just going to draw what I know is a radical graph, so it has a curve shape to it. So it'll look something like that. Okay, that was number 7 and 8 on the homework. Number 10, and I apologize for this, I realized it way late, but it actually had a typo. I had the negative sign in the wrong place, but I want to talk through it so that you can see what it actually should be. What we have is the step function. And let's talk about, what we see on the actual step function itself. So when I look at the step function, I see a few things. The first thing I notice is that each step has a length of 2. Okay, I see a length of 2. So I'm going to make note of that. Each step has a length of 2. Now, the other thing I notice is typically with our step functions, again, to kind of draw the parent graph on here for you so you can kind of compare what we actually have. I'm going to zoom in for a second. The step function normally begins here at 0, 0 and goes out to 1. And there's an open circle on the right-hand side. But if you start to look at what you actually see on this graph, you notice that the open circle has switched sides. So what's controlling that is that instead of having a closed circle and then moving to the right, we're actually moving backwards 2 units. So that's going to come into play. That's going to be part of my horizontal stretch. All right, so it's going to be part of the horizontal stretch. So my horizontal stretch is not only creating a length that's twice as long, but it's also reflecting the graph over the y-axis. Okay, so I know that's happening. Now, the next thing I know is that we have still a length of 1 between, oh, I shouldn't put it there. Let me get rid of that gray step because that's not really part of our graph. That's just a guide. We have a length of 1 between each step. Okay, so that tells me my vertical stretch didn't change at all. Okay, so here's what I know. I know I have a horizontal stretch of -2. I know that my vertical stretch is still 1. Now, the question becomes, which one of those steps corresponds to the step that would have begun here at 0, 0? And this is a question that's impossible to answer because unless I tell you which one corresponds to 0, 0, really any of them could correspond to 0, 0. So what I have to check for when I'm looking at my equations that are possible is which equations have a horizontal stretch of -2, a vertical stretch of 1. We'll start with that. Okay, so they all have a vertical stretch of 1. I see that because the 1 is your A value. And again, what we're looking at here is this. If we have our, we'll use C and D on this one. A has to be 1. Now B, if the stretch is -2, then what we're actually seeing in our equation is going to be -1/2. So when I look through at all three choices have those options. What's left is to determine, does the left-right shift in each of those equations actually correspond to the graph that we're seeing? So for this one, we see it's going to go right 2 and up 1. So if I look, I don't know what I just wrote there. If I look at my graph, and I'm always thinking about starting here at 0, 0, right? Did I go right 2 and up 1 to get a closed circle? And I did. So that one actually works out okay. And that actually is this point right here. Okay, so let's try the next one. The next one just has us going right 4. So now the question is, if I move from 0, 0 and go right 4, do I have a closed circle? And I do. So this actually also works. And then finally, we have this last equation that has us going up 2. So if I start at 0, 0 and I go up 2, do I have a closed circle? Yep, I sure do. So then this one works as well. So the answer is actually all of the above. All right, I hope that helps with those 2 problems from the homework. Let me know if you still have some questions, and I'll see you in class.